Guys, so we continue. Okay, so now we're on number 3 of the study guide. So it says for the volume of the sphere, V equals 4/3 pi r cubed. Find the average rate of change on the interval 2 to 7 inches. Okay, so we know the output is the volume, right? And it's saying over the interval of 2 to 7 inches. We know the variable here is r for radius. So that's going to be our input, and this is our output. Okay, so what's the formula for average rate of change? The change in the output over the change in the input. So let's make this, this is our output, so I'm going to turn it into a function real quick because this is just an equation right now. So let's say, we'll just go with f. F of r equals 4/3 pi r cubed, okay? And this equals v, output. Okay, so as always, we can already find the change in the input, final minus initial, so 7 minus 2. Now we need to do the change in the output, final minus initial. So we're going to do f of 7 minus f of 2, right? The output of the function when the input is 7 minus the output of the function when the input is 2. And we've done this before already, right? So f of 7, wherever we see an r, we're going to put a 7 instead. So equals 4/3 pi 7 cubed. F of 2 is 4/3 pi 2 cubed. Don't let the pi confuse you. Now it looks like a Roman numeral, but that's fine. Because this is just a constant, right? Pi is like 3.14. So anyways, you plug this in. So let's say again, this is some number a, this is some number b. We'll do a minus 2, a minus b over 7 minus 2. Plug that in and we'll get our average rate. Okay, so that is number 3. Moving on to number 4, we have functions b and k. Now b and k, are they the output, input, or name? They are the names, not the output, okay? So for a, it says use function notation to represent the change in the output of function k from an input of 6 to an input of 9. So from 6 to 9. We're starting at 6, so that's our initial, and this is our final. So we want to do the change of the output. We know that whenever we see change, we're probably going to do a minus, okay? And it's always going to be final minus initial. Now, we want the final and initial output. So that means that we're going to need to plug something in to one of these equations, right? So if we're looking at function f of x equals input, output. So we're going to need to use these functions and input these values. Okay, so we're using the function k, right? Not b. So we're going to do k of 9. This is going to show us the output of the function k when the input is 9, because 9 is our final input, minus k of 6, the output of the initial value, which is 6. Okay? That's all there is to it, just that. Whenever it asks for function notation, you're going to have the name and an input, and any variation of this. So here we had function and input minus function and input. Okay. B. Use function notation to represent the sum of the output. Sum means addition of the output of the function k at an input of -9, and then we switch it up. We have the output of B with an input of 6.12. Okay, so sum means that we're going to add something up. So we need to figure out what two things are we adding. So here is the output of the function k. We know how to do that, right? We have our, we have our function, right, at an input of -9. So our function is k, our input is -9. Once we plug it in, we get our output, right? And that's what we want to add, the output. Here's the same thing, function b, 6.12, and that's it, okay? It's not -9 plus 6.12, right? Because that would be adding the inputs. We want to add the outputs, okay? So don't get these confused. Oh, I'm so stuffy, I'm so sorry. Okay, moving on. C, use function to represent the average rate of change from the function k from the input 4.1 to 12.5. Okay. Initial, final. We're starting from here, going to 12.5. What is our formula for average rate of change? Change in the output over change in the input. So in this case, our function is k, right? So here we could say input 2 minus input 1, k of input 2 minus k of input 1, right? Because this gives us our outputs using the final and initial inputs. Did I say that correctly? This gives us our outputs using the final and initial inputs. Okay. So, and remember, we want to keep this in function notation, so we don't need to evaluate it. We don't need to plug it into our calculator. It's going to be left with a name, some inputs, and then any variation of this. Okay, so again, we know our change in our input, right? 12.5, which is our final, minus 4.1, which is our initial input. Now we need to put the change in our output. This is easy enough, right? We know our function. We just got to plug in our input values. So output of the final input value minus output of the initial input value. And that's it. Cool? Sound good? All right, awesome.